everyone. Greetings from a beautiful sunny day in London. I'd like to welcome you on behalf of EUNIC London to the third AI Science Café. My name is Przemysl Pela. I'm director of the Czech Center and the co-president of EUNIC London. So if you have joined our previous discussions, you know that EUNIC is an association of European Culture Institute and embassies in the UK. It's the main aim to promote European culture and foster mutual collaboration with the UK partners. Furthermore, EUNIC also expands in the new and uncharted territory of science and innovations, addressing topics of advanced technology, in particular the artificial intelligence. So with this in mind, we have prepared an annual series of discussions and debates on topics of AI and its interactions and impacts on various fields. So the first two discussions address ethical and philosophical dimensions of AI and impacts on creativity and arts. In today's theme, we will focus on AI contribution to smart mobility. As on one hand, mobility is one of our precious freedoms, it's also one of the main challenges in cities conglomerates on how to design mobility patterns to be sustainable, efficient, and environmentally friendly. There might be some solutions on a horizon, though still many questions remain, such as, will shared autonomous driving be part of a smart mobility solution? Will the electrical cars deliver environmentally friendly and sustainable mobility? Could or shall free public transportation service be part of a smart cities mobility solutions? These and other questions will be addressed and explored this evening. And I'm very pleased that we will do so with such a representative international panel of speakers from various professional backgrounds, AI mobility researchers, as well as practitioners, university experts from United Kingdom, Finland, Hungary, the Czech Republic, this time from the United States. So with this, I'm delighted to introduce the chair of the panel, well-acclaimed expert in the field of urban transformation, Professor Mike Keith from the University of Oxford, the director of COMPAS, which stands for Center of Migration Policy and Society. And among others, he's also the co-director of the University Future of Cities Network. So before I turn the floor to Mike, I'd like to thank and acknowledge a great support organizing this AI Science Café to many of our partners, particularly the Finnish Institute, namely to Nini Ledniemi, but also to the Hungarian Embassy and the Hungarian Culture Center, as well as to the Czech Center. So I wish you to have engaging and interesting discussion. So without any further ado, I would like to turn the floor to Mike. So Mike, please.
Many thanks for that. If I can people see the screen?
Yes.
Great. Okay. Thanks for the welcome, and thanks for the organization. We've got three speakers lined up with some fascinating material. And I understand the audience, we may have a mix of people with great expertise in this area and those with a more general interest. So I'm just here to set up in very quick terms some introductory thoughts really about how, for me at least, the interface of AI and smart mobility might raise some questions. I guess for me, when I was thinking about this series, there would be 4 questions that might relate to what's gone before, for those who've been in the Café series already, and as well as this particular subject tonight. And I guess my 4 questions are roughly as follows: that maybe we need to think about who is moving, about what is moving, how the new technologies actually disrupt the worlds we inhabit, but also how the science of AI and related sciences land in society, and what kind of moral dilemmas that poses. So those are kind of my 4 questions that I wanted to introduce to a future-oriented discussion, which I know begins with a sense that we have talked about futures before, We've talked about futures of smart mobility before. This is a slide from the 1960s from the architect Jeffrey Jellicoe as to what the future city might look like: a moving sidewalk, auto service, auto ramps. Their version of the technocratic future was something 60 odd years ago now, that even governments, this is the British government description of how they saw the city developing. So we know the images of the city, like Koolhaas's version of what he thought the city might look like, or even the late Zaha Hadid's version of Shanghai, all have a certain kind of futuristic thing that we might find on film, but also right the way down to the current president of China, Xi Jinping's version of how he will create an ecological civilization through a city to just out of Beijing, which will be the ideal type of the new sustainable urbanism, contemporary China, that is marked by AI, smart mobility, and ecological sustainability alike. So that there are kinds of technocratic ways of thinking about these futures that are, we know, we have seen before in different ways at different times. I think it is the case, though, that what we need to recognize is that there has been a profound change over the last 10 to 15 years. And I guess there are two slides that are really important, you know, what I'm showing, this one and the next one in a sense. And they relate to the fact that when we look at the world, and if we particularly look at a world which increasingly lives in cities, not least, and despite it maybe the COVID pandemic, when there's a lot of talk about cities hollowing out, the scale of the move to the cities globally is extraordinary, particularly in China, India, the global south. How we live in cities, though, is changing rapidly. And we know a very great deal about this in the immediate time of today, tomorrow, right now, the real time that we measure by data footprint generated by the millions of people that live particularly in the cities, but more generally. And I suppose the paradox of this kind of knowledge, there's someone called Mike Batty at UCL who has a kind of nice way of capturing this, that in some ways we know more and more about short-term futures, about immediate futures, about what you might be doing tomorrow because of what you did yesterday and many times before, but maybe much less about longer term futures because our way of living is changing so rapidly. So at the heart, I think, of our discussions tonight, we need to recognize the power of some of the new sciences to generate both new forms of data and also new ways of thinking about that data. These are the kind of the two core points of my introduction, if you like. And when I say new forms of data, I'm talking in very loose sense, particularly what is sometimes described as the new urban sciences. When we begin to think about cities and the way people live in cities that generate extraordinary digital footprints from almost every single device that you might encounter, the wearable devices, your Apple Watch that sends data back to your insurance company, the mass transit companies on the tube, the metro, the bus that record where you've been, the mobile phone records of where you've been, ID card systems in many countries, credit card records, and so on. These create various forms of what's commonly called big data, but also should give us a way of thinking about seeing the new mobilities. That means that what we are able to do is understand how people are moving about in all sorts of ways. There's an example of one of the projects we're working with, one of my colleagues in Shanghai, a project I referred to a couple of times, I'm afraid, tonight, a project called Peak Urban that tries to look at combining the new urban sciences with other ways of thinking about and seeing the world. And that shows how you can use phone records to understand how people are moving about and using green space for leisure on short term, on long term, in different kinds of cycles. So green space being incredibly important in a post-COVID world. But the way we treat this data has also changed rapidly. And in particular, AI becomes particularly significant here. And both in terms of how we are able to simulate, and we're going to be seeing examples of that in the contributions from colleagues today, but also the ways in which data can be analyzed with techniques such as machine learning, which takes huge amounts of data and then begins to model from that data new ways of thinking about futures that are not just about today and tomorrow, but a slightly longer term. And one of the examples that, again, on this slide here, there's this very short example of a piece of work done by colleagues in Medellin in Colombia, which is being picked up by the World Bank at the moment, where using the ways in which cities have grown across the whole of Latin America. There's an IP registered program called Urban Pixel, which is able to kind of use neural networks to predict growth patterns of cities in advance needs of logistics, of energy companies and so on, and is being deployed on the ground. What that means, though, is that we need to think about how these systems might evolve into in the future. And in that sense, what I just want to jump through very quickly is a couple of examples of the ways in which, when technologies land on the ground, they actually produce disruptions that we're not always familiar with. In terms of mobilities, Uber needs no introduction, but when we're thinking about these questions about who is moving, what is moving, we might also want to think about the fact that Uber has actually managed to lose very large amounts of money. It is basically betting on a long-term future in order to try to capture a marketplace in certain kinds of ride sharing. It also has certain controversies around it, not least around how Uber has arrived in South Africa, where Uber cars were attacked, in Brazil, where unions campaigned against it, but also in India, where the security of how you took your ride in an Uber created a tension between the power of the science and the drive sharing and the mobility, and on the other hand, the ways in which it was socially adopted. Similarly, we might look at not just people moving, but objects that move. You might think about basic health tools, such as an MRI scanner on the right and a defibrillator on the left. We've traditionally thought about how people move to a hospital, to a doctor. You move to an MRI scanner, but you need a certain speed to move. You need to kind of go there on a long-term appointment. We see across the world, the defibrillator takes health to the people. So cities like as diverse as Tokyo or Birmingham or many cities in Europe now try and make defibrillators as close to people as possible, because for cardiac arrest, the mobility of the object is as important as the mobility of the people itself. Because if you're within a short distance of a defibrillator, cardiac arrest success is measured in seconds, not in the taxi time it takes to get you to an MRI scanner in a hospital. So the whole real estate program of health provision sits alongside the smart mobilities of objects as well as the mobilities of people. And we see also that in these dilemmas, when we're thinking about these new mobilities, things like driverless cars that we'll hear about today, they land in place, but they create their own dilemmas. And Michal might mention this, we talked about this yesterday when he comes to his speech, but when we think about the dilemmas of mobilities, particularly driverless cars, they raise very old philosophical questions. The trolley question in philosophy about if I'm driving a train and I can run down, I see in front of me 20 people on the track, but I can flip to a different train line and run down deliberately one person when I've lost control of my train. That trolley dilemma is kind of replicated in many forms. And the slide that you see is taken from what MIT called their moral machine experiment. All of these things create, I guess, that sense of the fourth question, how we think about how science lands in the context of mobilities, and how we think of how science lands ethically. It ties into the work we're trying to do in the project on future cities known as Peak Urban, which if you would like to know more about, please have a look. But it also ties into the fantastic talks that we've got from our three speakers today. And so what I'm going to do is just like initially to open up by introducing our first speaker, just to give a run through of how we're going to work this. Each of the speakers will speak for approximately 10 minutes or so. We're going to take them back to back. I'll introduce each in turn. And we'll then try and stimulate a bit of discussion between the three speakers that we've got. And then after that, we will open up to questions from the audience. So please put your questions in the chat as things come through, and I'll try and draw on them as as we come to that later on in the program, but maybe put your questions while the speakers are contributing so that you don't forget them later on. But our first speaker today is Michal Čáp, who is working in Massachusetts Institute of Technology, MIT spin-off that is known as isee. He has a kind of experience in that commercial world, as well as a long experience in top institutions academically, MIT itself, but also at the AI Center at the Czech Technical University in Prague and in Delft in the Netherlands. So Michal, the floor is yours.
Thank you for the kind introduction. So let me share my screen. I think I need you to stop sharing first.
I need to,
Great, thank you. Okay, can you see my slides?
That's great.
Awesome. So today I'm going to talk about the results of our research, in which we try to gain some more insight into what are the fundamental limits of autonomous shared mobility. So this is a joint research with David Fiedler from Czech Technical University, Emilio Frazzoli from MIT, and Javier Alonso Mora from TU Delft. So private cars, they form an important part of urban mobility. There are many situations where they cannot be easily substituted by other forms of transport. For example, if you want to get to an area that is not well connected to public transport. So for example, today in London, 35% of all trips are done still in private cars. Yet, as we know, there are a number of problems connected with private vehicle transportation. One of them is that cities typically have insufficient road capacity, which leads to congestion. And also they typically have insufficient parking capacity. So the drivers, they spend a lot of time searching for a parking spot in most densely populated cities. A conventional answer to those two problems is to build more roads and build more parking structures. But this is increasingly difficult to do in densely populated cities because most of the land is already developed, and the only option left is to dig tunnels, which is extremely expensive. An alternative solution to this problem is to try to motivate people to actually share their vehicles. There's two things that you can do. One of them is car sharing, where we have multiple people that share one car over a single day. And that should, in theory, reduce the number of vehicles needed. And another one is ride sharing or ride pooling, where we have multiple people that share one vehicle simultaneously as a group. And that should reduce both the number of vehicles needed, but also the amount of vehicular traffic in the system. So there has been many attempts to make car sharing and ride sharing work on a peer-to-peer basis, but none of them really took off. None of them really became widespread. And the main reason is that those peer-to-peer systems are rather inconvenient. On the other hand, mobility on-demand systems, such as taxi or Uber, they can make those forms of sharing actually convenient, sometimes even more convenient than using your own car. But the main barrier to widespread adoption is that obviously is the price. It's more expensive than using your own private car. And this is where self-driving technology becomes interesting, because self-driving technology promises or enables creation of automated mobility on-demand systems that can offer point-to-point on-demand mobility at a price point that is potentially cheaper than using your own private car. So this is a business model of companies like Waymo, Cruise, Autonomy, and others. And the idea is that if you give people this mode of transport, it might make economic sense for them to not own a vehicle and instead use a system like this to get around the city. There's a debate on where this might lead to. There's a part of the debate is painting a utopian future where we have this system that allows us to save a lot of parking spaces, and those parking spaces, they get transformed into bike paths and parks. But you can also paint dystopian future where the city gets clogged by those aimlessly roaming large fleets of autonomous vehicles. And you can actually argue pretty convincingly for both. So our approach here is to build mathematical models that will actually allow us to understand what are the fundamental limits and inherent trade-offs in shared urban autonomous mobility. Specifically, we worked on a hypothetical scenario where we asked, what would happen if we try to actually replace all trips by private car in a city by an automated mobility on demand system? And in this specific case, we would assume that each vehicle is a single occupancy vehicle. We use the city of Prague as for our case study because we have access to a demand model. This demand model can fuse several data sources and synthesize a data set that is representative of 1 day of private car trips in Prague. And we take this data set and try to design a mobility on demand system that offers the same quality of service as we would have with our own cars. So the way we define it is that we want to guarantee that anytime you want a car, you will get it within 3 minutes. So this is non-trivial in any shared mobility system. And the reason is that cities typically have unbalanced structure of transportation demand. So here's an example. Imagine morning rush hour. You will have people that will want to travel from a residential area to their offices in a business area. And there will be relatively fewer people who want to travel in the opposite direction. So what will happen inevitably is that all the vehicles they will be rented in the residential area and returned in the business area. All the vehicles will start accumulating in the business area, and there will be shortage of vehicles in the residential area. The only way to counteract this process is to start sending empty vehicles in the opposite direction. And this is a process known as rebalancing. In this case, it's a relatively obvious what to do. Once the demand becomes a little more complex, then the solution is non-obvious. And you can actually show that an optimal solution to this problem is the one shown on this slide. So what we did here is that we have to solve this mathematical problem and to analyze it and find out how does an optimal rebalancing policy look. So in this case, we are able to come up with a policy that guarantees that the customers will never experience a shortage of vehicles in their area when they need them. So once we have an algorithm like that, we can take our travel demand, take our algorithm and simulate how would the system behave in status quo. That's the left picture, where everyone uses their own private vehicle. And in this hypothetical future, where all those the same demand of the same set of trips is served by a mobility on demand system that uses shared vehicles. So as we can see, we can reduce the number of vehicles needed to serve this 1 hour of demand from 122,000 to 33,000. So that's roughly a 4-fold reduction. So that's a big reduction in number of vehicles needed. But the price we pay for that is 32% extra traffic due to all those rebalancing trips. And this 32%, that's a fundamental number. You can show that there's actually no way to reduce that further, and you you can show that for most cities, for most demand data that you get roughly this number. So this is a problem. Now we are adding traffic to a system that is already operating on the edge of its capacity.
Michal, your slides are not moving. Did you know that? I think.
So what do you see now?
We see the title slide.
Oh no. Okay, so that's a hiccup. That's a hiccup.
It started moving just then.
Okay, so let me do this. Okay, so
Now
that's fit in. So now
we're
you
on
see.
7 to 8. Yeah.
Okay. Never mind. Okay, so this is the picture that I was just explaining. So we have data for the current state and the data for this hypothetical future where we apply the mobility on demand system. So as I said, now we have more traffic in our system, which is a problem. One way to resolve this problem is to actually start applying ride sharing, meaning you put multiple people in one car. Again, once you start doing that, there is this question on how do we actually find out which people should go to which car. We have an interesting mathematical problem. Given a fleet of vehicles and given your travel requests, find an optimal assignment of those travel requests to the vehicles that satisfies some notion of quality of service, but at the same time minimizes the amount of traffic that the system generates. So again, we were able to come up with an algorithm that is able to come up with an optimal solution to this problem. And we are able to run the same simulations using this optimal algorithm and see how much of a performance gain are we theoretically able to achieve in this setting. So as you can see, now we are able to go down from 122,000 vehicles all the way to 13,000 vehicles that do both car sharing and ride sharing. So that's 10-fold reduction in the number of vehicles, which translates also to an even larger reduction in terms of the parking space requirements. And even more importantly, we can see that the amount of traffic in the system reduces as well. So roughly to the half of the status quo. So to conclude, I was trying to show that self-driving technology has a potential to improve efficiency of urban transport, but the actual impact that we get through sharing is involves a lot of trade-offs, and it's sort of multifaceted, and many of the outcomes are not obvious, and therefore it's really important to carefully study the problem and to understand the dynamics of sharing. As I said in one of those previous slides, you know, when you start first thinking about car sharing, it's not completely obvious that this might actually reduce the number of vehicles needed, but increase the traffic. And those type of things become obvious once you start modeling those systems in a formal and rigorous ways. And also you start understanding better what are the trade-offs that you need to consider. And you can start thinking about what is the actual trade-off that we as a city or we as a policymakers want to achieve when we deploy those systems. So I'll end here, and I'm looking forward for the follow-up discussion. Thanks everyone for your attention.
Many thanks, Michal. We're going to move straight on to our second speaker, who is Laura Ruotsalainen. Laura is an associate professor of spatiotemporal data analysis at the Department of Computer Science at the University of Helsinki, working on machine learning algorithms for forming and analyzing accurate and reliable spatiotemporal data for the development of sustainable smart cities. So Laura, I hope I pronounced your name correctly, and over to you.
Yes, thank you. That sounds very good. So yes, in addition to being an associate professor at the University of Helsinki at the Department of Computer Science, I'm also a professor of Helsinki Institute of Sustainability Science, and therefore I wanted to talk today about how to use artificial intelligence for sustainable mobility. And I hope you can see now my slides well here.
We can see the slides and it's moving fine.
Okay, great. Thank you. So yes, the United Nations has said that sustainable development is the international community's most urgent priority. And they have set up sustainable development goals that are addressing many very important topics. And artificial intelligence plays a very important role on all of those. And it's also very important at this point to remember that even that the ecological sustainability is of course very important and requires very urgent actions. So also social and economic aspects are two of these three sustainability pillars, and they should be addressed too. And there are actually quite many things that violate the sustainability of present form of transportation. There are, for example, 1.35 million road traffic-based deaths per year globally, and then 10 million people are injured per year. And also it is very sad that 93% of these accidents are caused by a driver error. And then actually the road traffic deaths are the first leading cause of young people of 5 to 29 years old. And then also road traffic is very important source of greenhouse gas emissions. So for example, in Finland, 1/5 of all greenhouse gas emissions come from road traffic. And then also at the moment, the equality aspect is also violated. So people don't have equal opportunities for transport based on where they live, for example, or their personal traits, for example, not having a driving license. And it's not very surprising that the World Health Organization has set up two very immediate actions or goals that need immediate actions for in the coming years. Well, use of artificial intelligence will revolutionize the mobility in the near future. So as we heard already in the beginning, so there is a lot of data gathered and collected all the time. Cities are already equipped with different sensors that gather data, and also the citizens carry mobile devices that gather the data all the time. So then when we use the artificial intelligence methods for getting understanding, analyzing the data, we can get many important and good things done with those. So for example, we are able to optimize the routing. So when we are able to know where everyone is in the environment, and then we know what is going to happen in the near future, we are able to predict what is going to happen in the traffic. We can optimize the routing and get out of the congestions quite mainly. We are also able to combine different transportation modes very flexibly. And then, for example, there is already a concept called mobility as a service, MaaS, that is utilizing this and being developed all the time. We are able to know where people and traffic are flowing, and we know, for example, what are the places where people would like to be, and then kind of like make those more livable, or we know where are the dangerous places, and then we can get more sustainable developments based on those. So then we also heard a lot about autonomous driving, and I'm very convinced that this is one of the best solutions for the future sustainable mobility. So when we have the vehicle doing the understanding of what is going on in the environment and then concentrating on the driving, we get a lot of safety benefits. So the autonomous vehicle is all the time concentrating on the driving task and not, for example, using a smartphone at the same time. We can also get many good equality benefits from using the autonomous driving, because then also people who don't have the driving licenses get access to vehicles. And then also EU has also made a very interesting strategy of also introducing drones, so flying unmanned vehicles to the air. And this will of course also then help with the congestion issues and problems, and then free then some space for green areas and houses, for example. But there are of course some challenges that we also have to address when we are collecting a lot of data and using that for analysis. So we have to make sure that all the data that is needed is available for everyone. And then we have to create a system where people are willing to share their private data, and also companies who collect the data are willing to share the data among other users in the ecosystem, so that we can really get the benefit, but also make some rules for that, so that we don't harm anyone's business based on the data. And then of course we have to ensure that the user privacy is kept all the time. That is very important for then using the data for analysis. And also we have to make sure that the data is not biased, so that we really bring the views of all the citizens in the future smart cities, for example, into the analysis. So then when we are talking about mobility, of course, location and navigation are very essential parts of that. And then one of the strengths of artificial intelligence is that it is able to fuse and integrate different forms of data in the way that humans wouldn't be able to do, and get understanding that humans wouldn't be able to get out from the data. And then there are many challenges related to the location data needed for navigation. So for example, the satellite navigation that has traditionally been used for navigation is not really working in urban areas, and it's not working at all in indoor areas where, for example, the autonomous vehicles also have to enter. And then also we are looking at new technologies. So for example, the autonomous systems use optics quite a lot. Technology is called computer vision, and there are some challenges, but of course, very many benefits coming out from that too. And as said, one of the strengths of the artificial intelligence is that it is able to fuse all this very different data. For example, the satellite navigation data, the vision data, different sensor data, and then, for example, different radio signal data, like the future 5G signals, also for getting accurate and good navigation and location solution. Then also we can get other very important sustainability benefits for mobility using artificial intelligence, and really addressing now all the different 3 pillars of sustainability. We are running a project where we are fusing 3 different disciplines. So we are using methods developed and models developed in computer science department, then also socio-economical information, and then also air quality modeling in a project that is called KUSKUS, so Sustainable Urban Development Emerging from the Merger of Cutting-Edge Climate, Social and Computer Science. So we are developing methods with which we are able to model the traffic flow and then optimize the cities, and then provide information for city planning based on the traffic flow, then modeling the air quality, and then also modeling the socioeconomic population information, so that we are able to provide suggestions of how the cities and the traffic inside the cities should be done, so that we are really achieving the sustainable development goals there. And then this was all from me. Thank you.
Laura, thank you very much. We will move on to our third speaker straight away. Our third speaker is Dr. Zsolt Szalay, who has a background of several degrees in both engineering and business at the University of Technology and Economics in Hungary, but is currently still in Budapest, but he is the Associate Professor and Head of Department of Automotive Technologies at Budapest University of Technology and Economics. But also I'm really pleased that Zsolt has a very practical presentation, in the sense, I think he's talking about his role as Head of Research and Innovation at Szalay zone, the automotive proving ground in Hungary, used for Hungarian infrastructure for connected and automated vehicle testing. I think, Laura, we're going to need you to stop sharing your screen if possible, and then I can hand over to Zsolt. I think, great, and I think Zsolt,
I wasn't sharing anymore.
I'm sorry. Oh,
okay.
I'm sorry. Apologies. Many apologies. It was just coming up on my screen, so that was a false accusation. But Zsolt, over to you.
Thank you very much for the kind introduction. Yes, I'm in a very good position because the previous speakers has already paved me the road by means of also talking about AI, sustainability, and so on. And finally, I will come up with the emphasis of the importance of testing and validation. I will start with the message that in the Hungarian economy, the automotive industry plays an important role, an important part. And for this reason, the strategy of the Hungarian government also showed important messages towards this sector by means of also investing into a testing infrastructure by investing 150 million euro. So when we are talking about safe and sustainable transport, I would like to emphasize the importance of safety and security. This means that when we are talking about AI-based systems, so that artificial intelligence is playing an important role in the future transportation, by also meaning that the current AI-based systems are overperforming the human performance. And I think Laura showed on the presentation that due to the fact that more than 90% of the road accident can be traced back to human errors, there is a very high expectations from the automated mobility and autonomous mobility to overcome this situation. And AI has a very special role in that, also in the machine-based perception, so in the environment perception, but also in the decision making. And I can also continue with other examples. So for this reason, we have to also differentiate that in the future transportation, the AI-based systems provide also a very big challenge from the testing and validation point of view. Just to mention one, that the current regime is used to or was built up by the functional safety systems, testing and evaluating software that is deterministic software, so code-based software, and all of our testing procedures are based on that. And we have to face the situation that when we are talking about AI-based systems and AI-based software, that we really do not know how does it work or what is really inside. We just know that the output overperforms the human performance. So we have to work out new challenges. So when we approach this in Hungary, we said that these challenges can be formulated into a pyramid called Autonomous Vehicle Testing and Validation Pyramid. And we approached these challenges in 5 layers, starting from absolute virtualization, so from simulation and laboratory testing. Layer number 3 is the proving ground itself. And above that, there is limited public road and open public road testing to be safe, as I said, on the public roads. It is also important because there is a very big market competition, so that there are players and stakeholders that would like to be the first on the market with their autonomous or highly automated solutions. But it has to be taken into consideration that with those systems, we should not arrive early on the public road, because that would set back the public acceptance of these new technologies. Okay, so this is the sketch of the proving ground. This is a 2 kilometers times 2 kilometers area, so more than 260 acres. And as I said, the overall investment is around 150 million euros. What is unique in the Szalay zone Hungarian proving ground is that this was the first proving ground that was not only designed for the so-called conventional or endurance vehicle testing, but it was designed for the specific requirements of connected and automated mobility. As you can see, there are also high-speed elements, also dynamic plate braking surfaces, but there are also artificial urban areas, the smart city zone. And there is also, for example, a motorway section, which does not part of any conventional proving ground. And beyond the fences of the proving ground, there are also university research center, innovation center. So we would like to create Zalazon as an innovation hub here. We were talked about the future cities. So for this reason, we also implemented a smart city zone within Zalazon. This is a 20 acres area. And from the perspective of the usage, it is divided into 5 subsections. Section number 1 is the so-called low-speed parking area. There is a logistics yard for automated yard maneuvering testing. There are surface parking areas, and there is also parking garage for volley parking. Number 2 is the multi-lane high-speed area. This is 700 meters long and 2 times 4 lanes with different pavement surfaces and road cross sections. There is also a downtown area with buildings and building facades relative high and also built from glass or steel, like in the downtown area. There is also a suburban area with residential building made from wood, brick, and ceramics. And in the outskirts, there are 14 different T-junctions that are in some ways specific for the connected and automated vehicles, for challenging for them. There is also a full coverage of the V2X or vehicle to everything communication devices, also in the latest technology of mobile communication, so 4G and 5G, and also the other physical medium, the Wi-Fi based, or in other words, DSRC, dedicated short-range communications, or ITS-G5 network. So we have full coverage to provide the communication facilities between the vehicles and also with the infrastructure. This video shows that when a vehicle was proven to be safe in the premises of the proving ground, they can go out to the city of Zalaegerszeg and also to the public roads in Hungary. I do not know whether you are aware of that, but since 2017 April, so more than 4 years by now, it is legal to test automated vehicle functions on public roads in Hungary without territorial limitation or without timing limitation. So there is a procedure to acquire the license for the automotive developer company. The highest ranking officer of the company is liable for any consequences. But when they are going through the procedure and verify their internal procedures, the vehicle is safe and also the test personnel is approved, they can get the license and they can use all roads in Hungary for testing. I would like to draw your attention to this M76 highway, which is now being constructed in Hungary. And this road will be as smart as technically possible. So this 12-kilometer section here will be this fully sensored 12-kilometer long section, which could be easily closed for testing. And the testing speed can go up to 270 kilometers per hour. And finally, I would like to also show that there is an international cooperation with our Austrian and Slovenian partners, creating a 3-country cross-border testing triangle. So there are also live cross-border testing sections. And to prove that we are not just talking about the testing and validation, but also we try to prepare for the safe operation of those vehicles, I would like to just mention a measurement campaign that we recently carried out. We closed the 3.5 kilometer long section on a Hungarian highway, and also with our Austrian partners, we carried out measurements on that. We created the full digital twin of that. We equipped this road section with sensors and with 5G communication. And all those vehicles that were traveling were equipped with differential GNSS centimeter precision localization systems, and we were carrying out measurements on that, more than 100 scenarios and 52 measurements, and we gained really valuable results how the future infrastructure could be intelligent, supporting the intelligent road vehicle, creating together safe and sustainable traffic. Thank you very much for your attention.
Thank you, Zsolt. And could I ask, maybe at this point, if everybody can, the contributors can put on their cameras so that the audience can see. I want to begin by thanking all of the speakers for their contributions. I thought they were all very provocative. I just want to kind of maybe start the discussion by just kind of drawing a couple of comparisons across those contributions. That in a sense, Michal's exercise for me is almost like a thought exercise in the abstract of what might be. And I guess, Laura, part of the talk that was fascinating in many regards, but it was also stressing strongly the balance between the social, the ecological, the economic within the UN sustainability goals, that is partly about what should be. So what might be, what should be. And in a sense, Zsolt, I suppose, was looking very much at what is. So it is a very unfair characterization of complicated and subtle presentations, but that there is a sense of what might be, what should be, and what is, I guess, as we see in these three presentations, which is quite provocative. And I suppose in that spirit, it kind of made me think, while you were talking about the ways in which these places that we live, mostly cities, not all cities, but are developing, are always about interactions between different kinds of systems. So we're talking about mobility systems today, but as you described, we're talking about, in Michal's discussion, the sense of work patterns and mobility on the one hand. In Laura's, a kind of a whole variety of lifestyle behaviors and mobility. But in Zsolt's also just the way people use roads for absolutely everything, which is maybe going to work, but maybe in leisure, maybe. And so that in turn, I think, makes us think about how cities are always what are sometimes described as not just systems, but systems of systems. So we have transport systems alongside economic systems, alongside ecological systems. And these are characterized by interfaces, as it were, between these different systems. So I wanted to kind of maybe begin our discussion to kind of provoke the thinkers that we have with us, who have produced very stimulating accounts of what might be, what should be, and what is. Yeah. To say, maybe if I can ask each of you in turn to say, sorry, if people can switch off their mics, I think, for the moment. I think we've got somebody else joining in, but please, you will get a chance. But maybe if our speakers might say a word or two, and I'll add a kind of question for each of them just to kick us off, about how these systems might interface. So in Michal, in terms of your presentation, I was struck by the fact that there's a significant difference between whether people are sharing and whether you just rotate the autonomous vehicles between people. And the sharing, I think, is more than in your data. I think it's an exponential decrease in cars or in vehicles rather than a linear increase. So I was just thinking about what the social protocols are to encourage people to share, but also whether there are any scaling effects of what of how your model works. And so that's the question to Michal. To Laura, most obviously you gave us this very persuasive presentation around the importance of the three pillars of the UN Sustainability Development Goals. And I was wondering if you might think about where there are trade-offs, where they're not necessarily always in line with each other. In particular, I guess you stressed equality as one of the dimensions of what you were saying. And we know many places that we live in, many cities that emerge are not characterized by strong equality. But I was just wondering how the trade-offs between equality and the other dimensions of sustainability work within the spatiotemporal algorithms you're working. working with. And for Zsolt, I guess my question likewise is to ask you to maybe think about the interfaces of the models you have with the reality that's also out there, even though yours is the closest to what is, if you like. But in your case, Zsolt, maybe I was going to start with that sense that you had a zoning as part of the setup of the suburban and the downtown, and I'm just wondering how much cities of the future will be zoned in that kind of imagination that we have, and what the difference might be in terms of how you work on your the zone that you described to us. But that hopefully might kick us off. But Michal, do you want to join in? And please, as colleagues, please feel free to come back to kind of either ask questions of each other or raise points about each other at this stage. Michal.
Great, thanks for your questions. So first question is, very relevant. So we were somewhat silently assuming that when we give people a shared mode of transportation, they will just use it. And that is a very strong assumption. I believe that obviously people have different preferences, but I think that the only effective mechanism is a financial incentive. That's what forces us to share other assets, right? For example, that's why students share apartments because it's cheaper. And there's an interesting question: how do you make it work? What is a mechanism that will sort of make it economically beneficial or economically rational to choose a shared mode of transportation over a private mode of transportation? I mean, obviously, in the absence of constraints, most people would prefer using a private car, ideally a huge private car. But the problem is that the capacity of our roads is limited, right? I actually, we thought about this a lot, and the only solution that I could think about, it's also a solution that is extremely unpopular, is essentially some conventional name for this is congestion pricing. Essentially, the idea is that you start charging for use of the infrastructure. Ideally, you start charging for sort of how much and how long you use the infrastructure. So essentially, you pay for each meter used and each second used of the road. And if you think about it, this is forcing you to use the infrastructure as efficiently as possible. So suppose that you would normally pay $5 for an hour or for 10 minutes spent on a road of London. Now, if you find 3 other people that are willing to travel with you, now you can sort of distribute this cost among them, right? So then you have this sort of market force that is essentially allowing almost like a private, like a distributed public transport system to emerge. Mm-hmm. So I think that's a mechanism that I would think would work. But when we were talking to cities about it, they would usually agree, but they would say this is impossible to make happen, mostly for political reasons.
Okay, thanks, Michal. If I could remind people, we've got a few questions coming forward, and so I'm not lost them at all. We'll be coming to them, but if other people want to add questions to the chat, please do so, and we'll be coming to those shortly. But Laura, you yourself.
Okay, thank you. Yes, so the equality question is not very easy one, and I actually found there 3 different layers that I could also comment. So first, saying that the easiest one is, of course, that when you ask that how do we make sure that the data that we use in spatial temporal analysis is equal. So that's probably the easiest part. So kind of like analyzing and checking that the data is really kind of like really gathering all the phenomena and all the people in where the data has been collected. But then asking that how kind of like making the whole mobility and cities equal, that's a quite difficult question. So most likely the only way is as in all equality question is to kind of like raise the awareness and concentrate on those and make sure that the decisions are made so that all minorities are also taking into account there and acknowledged. But then I think also kind of like one of the most difficult questions related to equality and mobility is most likely the thing that also I think Michal addresses that what will happen so when everyone will have kind of like the opportunity to have a car. So if we still stay in the kind of like the traditional way that people have their own private cars and then everyone will have access to a private car, then I think that we are not going any way near to the kind of like the sustainable development goals. So in that sense, I also am a very strong supporter of Michal's shared vehicle systems for the future and autonomous shared vehicles.
Thank you. Zsolt.
Yeah, thank you very much for raising those very interesting questions. I picked at two. First, this system of systems approach you mentioned. We also believe that the complexity of the current systems are so challenging that also from the testing, also the type approval process must be changed and will be changed in the near future. So for example, an easy example is that the brake system could be easily tested and all the situations and all the surfaces could be tested. And after proving ground test, one could say that this brake system and this vehicle is capable of traveling safely on public roads. But now, due to this complexity and the potential integration problem of those systems, such a proving ground test will not be enough to say that a vehicle is safe enough to go on public road. What we can say rather in the future is that one vehicle will not pass a certain test on a proving ground. We can say that it's definitely not valid or not allowed, should not be allowed to go on public roads. So for this reason, we strongly believe, or my future perspective is that in the type approval process, there will also be a part of simulation, strongly simulation. There will be also part of proving ground tests as in the previous ways, and there will also be public road testing and a certain composition of those things incorporated with, as I said, the process-based audit and analysis of the companies so that they operate safe procedures resulting in safe software code. So this composition will hopefully result in safe transportation devices on public roads. So this is about the system of systems challenges. The other thing you mentioned, I would like to thank you very much, because when we thought about this smart city and smart city zones, we thought we were smart also and clever enough to at least draw up the future of the cities. What we did is that we gathered experts, not only from Hungary, but also for abroad. And it was more than a 10-month working together to put the requirement specifications, what should be in a proving ground, which is dedicated for connected and automated vehicle testing. And there were automotive experts, and there were also info communication experts. But maybe it was a problem not to ask urban designers of the future or something like that into that. And after that, it turned out that maybe this is very pragmatic and also shows for the near future. But this was the outcome of this requirement specification process, that there are certain areas or operational domains where these vehicles will travel that should be carefully tested. And for this reason, there is parking related, downtown related, suburban related, and cross-section or T-junction related challenges. But I would be glad to continue the discussions with you and provide you further details about our smart city zone and to hear your views about what should be also incorporated in the future test of smart cities. Thank you very much.
Thanks, Zsolt. I think we should move to bring in our audience here, and we have a stack of questions. So I'm going to try and take quite a few, but because some of them are very individual questions, so maybe if our speakers can be ready to ask these, but I'll run through them. So a question that I won't take as for me, but I think it actually ties to Michal, to you in a way, because it relates to what I was asking, is from Andres Galani. And it was on journey pooling, about what do you think made Uber's pooling options disappear in European cities, which I guess again is about a sharing question, but any of us can answer well, whether we can answer it correctly or not, I don't know the answer necessarily, but please, if you have an opinion on that question, come in. But also very specifically on rebalancing, this is for you, Michal. Uber took the decision to approach this via reshaping demand, e.g. economic pressure by surge pricing. Looking at your Prague model, do you think there's a way to find the right balance between financial approaches and fairness with regards to access to trips? But that obviously kind of triggers some of the points that Laura was making as well. From Maggie Halkova, we have a very straightforward question, I think, to Zsolt, to yourself, which is how many cars can be tested in the area that you're describing. From Alec, who is also very complimentary about our three speakers' contributions, and I guess this is a question to all three of you, which is to ask, how much consultation with citizens is there to guide the way forward? Do people actually want what is being proposed? So maybe you can have a go on that, but I guess let me just come very quickly to the last couple of questions. So we've got quite a lot to come back to, and I'll try. Please just answer one or two when you come back. From Angus McKinnon is a specific one for you, Michal, which is to ask on the Prague model, how do the fuel energy requirements of the scenarios compare? So there's a couple of direct ones to yourself. And then one more question. I'm sorry to get, I don't want to exclude everybody, but is how is right to privacy taken into consideration when collecting the data to create systems based on AI, so that the society is not basically over-surveyed, over-controlled? Again, I think, Laura, you've already partly touched on that, but please, I suggest maybe we go in a slightly different order this time, so we don't get the same. Why don't we take Laura first with some of the general questions? Michal, you've got a couple of very specific ones, and then I'll come back to yourself, Zsolt, since you had the. I don't want to come back to you too quickly. So, Laura, why don't you start us off?
Okay, so can I then just select which one I
Absolutely, you get to choose, and then if Zsolt gets left with all the other questions, the difficult questions, then I might come back to you.
Yeah, well, I will take definitely the data question, because that's something that I'm dealing quite a lot with at the moment. So I would say that in Europe we are in quite good states for making sure that the privacy is protected and that the data is used as it should. So we have already had for many years the GDPR, so the General Data Protection Regulation in EU, or valid and being used. So therefore our data is not collected usually, so that we don't know that. And then definitely the other very important thing is that at the moment there is this EU regulation on artificial intelligence is under preparation, and that's under comments at the moment. And that is also definitely bringing a lot of kind of like security for the citizens, the users, so that the data is not used for harmful purposes. So in that sense, I would say that we are quite well set in EU at this moment, or Europe.
Okay. Thank you, Michal.
So, yeah, very good questions about why Uberpool stopped working in Europe. Yeah, I think the reason is that that ties back to the scaling question. But for ride pooling to work, you need scale, and you actually need a very high penetration of many people who are using the service, so that you can find the matches. And we have even done some studies on what level of penetration you need for the ride pooling to start working, and these are very high numbers. So if you need you need units of percents before you can sort of reasonably start finding matches between people. Unless you focus specifically on things like, for example, going to the airport or from the airport, that sort of have like single origin or single destinations. These are sort of special cases, but in general, it's very hard to make it work in small scale. So I think they just weren't able to make it profitable because they weren't able to reach the sort of the tipping point where you actually make profit.
And there was also about the fuel energy requirements in terms of
right. So that's actually the vehicular traffic metric that also represents the energy requirements. So the answer is the pure car sharing. That's the scenario 1 is 30% needs 30% extra energy due to the rebalancing trips. Which is a problem right now. Now you are you saved a lot of parking spaces, but now your transportation system consumes 30% extra energy. The third scenario that reduces the total energy to roughly 1/2.
Okay, thank you. I'm noting that I'm not sure whether we're addressing the privacy question here. I might come back to people on this, but Zsolt, there are a couple of specific questions for yourself about the how many cars can be simultaneously tested in the zone you described to us.
Zsolt is a big proving ground, and the smart city zone is only one part of that. So according to our calculation, some 10th of vehicles, so 50, 60 vehicle can use it at the same time. And also it was the reason behind making the smart city, the artificial urban area, into separate zones so that separate customers can use the area at the same time in a confident way so that they do not disturb each other because they are also carrying out sensitive tests and sensitive measurements.
Thanks, Zsolt. We're moving towards the end, folks. So we have one more question from the audience, but also, I guess, just to give you the last chance, please, if there's any other comments you wish to add in fairly short responses. I'll ask maybe everybody to come back to Monika Marikova's question about privacy a little bit. How is privacy taken into consideration? I'd put in just a second question myself, a very short one, which is that we work in my team work quite a lot in cities in Africa, in India, and in South America, where cities are characterized by very high levels of informality. And so I wondered how a lot of kind of European type models travel or might travel in that kind of context. But also there's a question from we have two other questions. Sorry, there's one just added as well. Two more questions. So you're going to have to choose your favorite, I'm afraid. That a question from Andrzej Martinek, where he makes the point that planners quite often don't take into account motorcycles as a transportation solutions. And he says he's seen an example by Oxford Council that is one example of that. So he asks, how are motorcyclists viewed in the big picture for, I guess, each of you or any of you on that one? And then from our host as well, maybe to conclude, could speakers take an educated guess when we're going to see in the Western world a majority? This is your quiz question to close the evening. What date do you think we will see a majority of self-driving vehicles in the West? So I think, Zsolt, you get the chance to start first since you got last, and I'll go in a different order. Zsolt, yourself.
Yes, thank you. So what I feel is that it still takes time that these highly automated or autonomous vehicles will appear on the European public roads. And also we have to mention, you also mentioned that there are big differences in cities, like in the US, you know, this rectangular format cities or the European traditional ones. And from the traffic point of view, we do not mention Istanbul or an Indian city. So we have to achieve all these steps to be able to create a safe transportation for that.
And your date?
I think at the end of this decade, there will be level 4 automation on highways.
That's a politician's answer, I think. I will let you off. Laura, you have to answer the quiz question with a single date, I think.
Okay, well, I would then be a bit more optimistic. I would say that maturity already 2030, based on that. I think that the technology is getting very mature, and also I think there is so big fuss and preparation going on this topic, and especially in Finland, I think the majority of the city leaders also believe that this is one of the solutions for the sustainable development, or achieving the sustainable development goals. So I would say that there is quite strong push for this.
How about the privacy question and the other parts of the world question, or the motorbike question? What about
well, the privacy, I think I already said that.
I think you did talk about the privacy.
Yeah, it's something that I'm quite kind of like, and also, well, I could, if I can still continue, I would also tie this to the other question that I also found very interesting in the chat, that how the citizens taking kind of like into account here, and do we discuss with them? So I would say that kind of like for this whole thing to realize and come to reality means that the citizens and the users, they have to accept the kind of like the solutions and the ideas, and then these both go to the same thing, that if the citizens are not happy what we are doing and the privacy is not protected, they won't adapt the new solutions. So in that sense, everything will fail. So that also forces everyone to also take care of these and really consider these questions.
Thank you, Michal.
Yeah, I think 2037.
And you don't want to answer the other question. Okay. On that point, can I hand back to our hosts after thanking all of our speakers for such a really interesting discussion?
Oh, that's wonderful. Thank you for the specific answer to the last questions of the quiz. It seems that's clearly going to be in our lifetime. So that's wonderful. On the more serious note, thank you very much for this quite fascinating and interesting discussions. And I think it proves the various angles and points of view as being more on the practical side and also on the research and academia. I think it makes really lively debate. So thank you very much once again to Laura, Zsolt, Michal, and of course, chair of the panel, Michael Keith. Also like to thank all of you who stayed with us throughout all the discussions, despite the beautiful weather outside. It is here in London. And as I mentioned, the AI Science Café series will continue after the summer months. So we will be back in September and we'll have discussions on AI and personal security. So this all that. So thanks again and have a lovely evening. Thank you.
Thank you.